Radioactivity is dangerous. Every process around radioactive materials has risks that need to be accounted for. However, testing is needed for these materials, whether for research or for manufacturing. We can't just ignore the radioactive materials. So, we develop a Glovebox. This lets us work safely and efficiently with radioactive materials. By securing the materials in a sealed container and performing the work in a ventilated environment, we can reduce the risk of exposure to workers while still not impairing the work too much. And in the last 50 years, these glove boxes have not seen improvements or innovations. The picture on the left is from 1975, while the picture on the right is from 2022. When you put these two side by side, it's glaring how little innovations these have experienced.
To begin this project, the team conducted preliminary research. This was to help gain familiarity with glove boxes, their applications, and how they were commonly designed. The team then moved on to focused research, in which the team researched specific glove box design topics that LANL emphasized as crucial for the design process. The team then conducted material research to help find common or new glove box materials that could be used in our design. After this, the team evaluated their research and they organized what they had found in order to make comparisons between the design features and materials. Then the team went on to the design process, in which they had to create 3 prototypes to show LANL. The following prototypes were created. Prototype 1, Box, which focuses on innovation. Prototype 2, Lil Lethargic, which focuses on ergonomics. And Prototype 3, the Middle Child, which resembles a more traditional glove box design with some innovative modifications.
Early on in the semester, Section 1, which is down selection, took place, where one final design was chosen out of the 3 that were made last semester. The final design was refined and finalized so that way it could begin being blueprinted. Once it was being blueprinted, the blueprints were detailed so that way procurement could happen. With the blueprints made and materials ordered, fabrication could take place. For the fabrication phase of the project, we are using 1/2-inch and 1/4-inch thick plywood for the walls of the entire box. The frame of the box is being made with 10 series aluminum extrusion and all the materials needed to connect to those. And for electronics, we are using a camera system with cameras, DVRs, and a computer monitor, along with acrylic sheets for the cameras to peer into while the box is in use for ergonomic testing. And the gloves we are using were sent to us by LANL.
Upon completion of Glovebox fabrication, the team will transition to Glovebox assessment. The first phase of assessment will be testing. During this phase, the user of the Glovebox will perform 3 separate tasks within the Glovebox. The first task will be to measure an object with digital calipers. The results of this task will be used to evaluate camera quality and the overall effectiveness of viewing Glovebox contents through a screen rather than directly through a window. The second task will involve the user reaching various locations within the Glovebox to evaluate reachability. The final task was created to evaluate overall Glovebox usability by employing work with miniature cups. The user will be asked to arrange the cups in various formations, such as in a line and stacked. After testing is completed, the team will move on to analyze the collected data. Both qualitative and quantitative data will be collected from testing. Once analysis is complete, all findings will be shared with LANL.